design. So we have to do that the concrete design there, right? Okay. So just go in the options design, there is options concrete frame design. Okay. So first we have to check the IS code. Okay. And the safety factor of concrete and steel by using that the options view, revise and preferences. Okay. So we have to click on that. So design code already it is taken IS456. If it is not taken from there, then you have to select that the IS456 from there. Okay. The safety factor for the steel that is the 1.15, so it is also okay. And for the concrete 1.5, right? Okay. Now after that, just you have to click OK. After checking, just next go on the concrete design. That is the rebar selections rules for columns. Okay. Rebar selections rules for column. And here are the two more things given there. The options one for detailing for non-seismic requirement and detailing for seismic requirement. So what is the difference between both? Yes.
Like for earthquake non-seismic requirement.
Yes. Right now we are not applied that the earthquake load. Yes or no? Or the seismic load. So we have to do that the rebar selections for only non-seismic requirement. But when I apply that the seismic load, okay, right? So we have to do that the detailing for non-seismic and seismic both, okay,
Right.
on the both parts. So we have to only cover this part only on the vertical load. So one more thing, you have to provide that the bar size not less than 12 mm bar in the beam and column. You have to remember this one, okay?
Right.
Okay. So here the smallest bar size that is the 12 mm bar, and the largest bar size I prefer that is the 20 mm bars. Okay, right?
Okay.
Largest bar size how we can take? It's all taken by the availability of site. Okay. What is the size of bar we have purchased? Okay. So all that's why we have used that the largest bar size we have to use not more than 20 mm bars. Okay. Largest bar size 20 mm, it means that in our constructions we don't have to use that the 20 mm bars. Okay, more than 20
very
mm.
high rise buildings they use more than 20.
Yes, you can use that. You have to just change that the criteria for them. Okay, right. Now the next one, what is the meaning of ties?
Stirrups.
Yes, stirrups. What is the another name of stirrups?
Rebars.
No, not rebar. Rebar is the reinforcement bar. Okay, that is the main steel.
Including of
yes, main steel. And rebar means that is the main steel, and stirrups both are rebar. Okay, so you just if you don't know that, you just note it down. The another name of tie bar, that is the ring bar. Okay, that is the stirrups, that is the tie bars. Okay, that is the distribution bar. All are the name of tie bars and stirrups. Okay, fine. So in the tie bars we have to select minimum, that is the 8 mm bars, not provide that less than 8 mm. Okay, fine. And the largest bar size for the tie, that is the 12 mm bars, is sufficient. Okay. Okay. Now the next one, that is the minimum bar spacings, minimum spacing of ties, that is the 120 or 100, you can put 100. Okay. And the maximum spacing, that is the 300 I have taken. Okay, understood?
These are the spacing between the stirrups.
Yes, the spacing between the two stirrups, we don't have to provide less than 100 mm. Okay, and not more than 300 mm.
Okay.
It means that we have to provide that the space that in the, if we have to add that the stirrups, it means that there is a in range between 100 to 300, right?
Right.
Okay, fine.
Mr. Sano, this is a standard you are following, right?
Yes, this is the standard we are following. Okay, we have to decide that the range. Okay,
right.
Yes, according to that, it specifies that if your result will be okay, then it designed according to that. Otherwise, it change that the reinforcement according to the loading conditions. Okay.
Right.
That's why I have taken in the column that is the reinforcement to be checked. I have not directly taken reinforcement to be designed. Okay. So first I check that.
Right.
After that it will be okay. Then our design will be okay. Okay.
Yeah. Yeah. For the seismic requirement, we just leave it as it is.
Yes, we have just leave it as it is. Okay, because we have not applied any seismic load, so we don't go for the result in that. Okay, because this is the default value. So according to that, it take that the data. Okay, but we don't have to follow that data. Okay, we have to follow only this data.
Non-seismic.
Okay. Yes. Now after that we have to just click OK. Now the next one in the design, concrete frame design for the rebar selections rule for beams. Now next one for the beams. Then click on the options beam or column, whatever you want. Okay. And before that, what we have to do? We have to first unlock the model. Okay. Right. So you can check that. Now we have to see that the result. So just go in the elevations, so we can see that the result very easily. Okay. So see that this is the top steel of beam. Yes or no? And this is the bottom steel of beam. Okay. That is the area of steel, and this is the area of steel for the column. Okay. What is the area?
Why it is showing as 48?
Yes.
Why it is
This is
showing
the maximum area. It is showing 193, and minimum area it is showing 48. Okay. When you want to see that the result in the details view, you have to just right click on the beam. Okay, so you see that this is the top steel, right? Yes or no? And this is the bottom steel. So where it is minimum and where it is maximum. So one part that is the minimum and another one part is a maximum. So same here. This is the minimum. This is the maximum. Minimum, maximum. Okay. So like that, it when it is going the minimum and maximum value, then it will be the balance the conditions, right?
Yeah.
Okay. And this is the shear steel. What is the shear steel? What is the shear steel? Yes, Munir. What is the shear steel?
No idea, Mr.
Shear steel is basically the stirrups. Okay, the area of stirrups. Shear is basically stirrups. Okay, right? And this is the top steel and bottom steel. That is the main steel, longitudinal steel. Okay. Yes. Right. And if you want to check by the summary, so here is the option summary. You can export into the Word format from there. You see that it's created that the report, so you can read one by one and you can check eachly. Yes or no? The details about that beam. Fine. Staad Pro never provide that the informations like that. Yes or no, Praveen?
How to save this file?
Yes, if you want to save that, then there is a options export to the Word document. Okay. If you want to export this summary result or flexural results or shear details, which one you want to export? Click on that and then click on the options export to Word document. Okay. And then go to the desktop and this is a summary. Okay. I have just saved this one. Okay. So it will be saved in the Word format, right? And same like that, we have to just click on the options column. So you can see that what is the size of column, at which story the column will be, what is the name of column, that is the capacity ratio of column, that is the major reinforcement, and that is the minor reinforcement. Okay, right? Yes or no? Or same here.
What is the meaning of minor and major?
Same, that is the top steel and bottom steel. For that's why. So in the column it is showing that the top steel and bottom steel, right? Okay. And in the column it is showing that the major reinforcement and minor reinforcement.
I think the outer and internal.
Major reinforcement and minor reinforcement is basically when we provide that the steel. So we have provided that at the corner that is the 16 mm bars. Yes or no? So in that case the area will be increased in that there, and in the mid we have provided that the 12 mm bars. So in that case the area will be reduced there. So that is the major and minor reinforcement. Okay, and same like that, if you want to check by the details, then you click that interaction curve. So here you see that this is the interactions curve. Okay, that is the graph between the force and moment. This is the graph in between the force and moment. Okay, same like that. If you want to go for the summary, flexure detail, shear detail. What is the full form of BCCR?
No idea.
Yes, Munir, BCCR. What is the full form of BCCR?
BCCR.
Have you heard that the name beam column capacity ratio?
Yeah, I
That is okay. BCCR. Beam column capacity ratio.
reaction
Capacity ratio, not reaction.
Ratio.
ratio, right?
Okay, so any query in the checking of output result in the design?
No. What about the envelope?
Envelope is another things. Okay,
Okay.
that is used for the another part.
Okay.
And the envelope is not matter. Okay,
Okay.
so that's why I have not explained this one.
Okay.
But if you want to check that the result, you can understood better. You know that what are the details given there. Yes or no?
Right.
Fine.
Mr. Sono, at the bottom here we have a flex, details, share, joint share.
Yes. Same
Like
things. Same things are always
Yeah.
on there also.
No, I mean in this, like we can change the value.
No,
Or
no,
we can't.
we can't change the value. If you want to go in the Word file, okay. If you export in the Word, then you can manipulate the result from there. Okay.
Right.
But there we can't. Okay.
Okay.
Yes. So this is the design result. Okay. And now if you want to see that the more result, okay. This is the longitudinal area reinforcement, right? Now, if any result, if you want to check that, okay. So in that case, you have to go in the options design, concrete frame design, and that is the display design information. Okay. Display design informations. So this is the longitudinal reinforcement area it is specified. Next data we have to check, that is the rebar percentage, and then apply. So you see that the percentage of steel,
Okay.
right? This is the percentage of steel, and you have to remember that the percentage of steel not exceed that the 2% in the beam and column. Okay, if it exceeds that the more than 2%, it means that your project cost will be high. Okay.
Yeah, because the steel we must be used more.
Yes. If you use that the minimum steel, it means that your project will be under the budget. Okay, not over the budget.
But here we have exceed 2%, 0.24.
0.2.
It is not exceed 2%, not 0.24. This is the 0.24%. It is less than 2%. Yes or no?
Okay.
0.2 and 2 is the other value now. Right?
Yeah, I thought we need to multiply it by 10.
Yes. Now the next one, that is the shear reinforcement steel. This one.
Stirrups.
That I have shown in the tables. Yes or no? That is the major reinforcement and minor reinforcement. Yes or no? Understood?
Yeah.
So understood how we have to check the result.
Okay.
Now next part we have to go in the options, that is the detailing. Okay. So now we convert this one into the 3D view. Now next go in the first one, that is the detailing preferences. Okay. Check that the unit, which unit we have to design, either in the metric or US, in the feet or inch, or in which unit we have to provide that the final drawing. That is the metric, right? So you have to select that the metric, then the dimensions unit. The length will be calculated in the meter. Okay. The sections and thickness we calculate in the millimeter. Rebar spacing also in the millimeter, and force we have calculated in inch. That is the kilometer.
Okay.
Now the next one, that is the rebar length. Okay, that is for the material quantity unit. Okay, rebar length, slab area, concrete value, and rebar weight we have to use in the kilogram. Okay, fine. Next, click OK. Next we have to go in the options detailing concrete component preferences, and now we have to use that beam. Okay. Yes, only beam, and you have to in the beam options, you see that the visual in frame elevations what? That is the section name and sequence number. So also visual in the frame plan, that is the section name and sequence number. Okay, fine.
Okay.
And now after that, this is the settings you have to prefer, not think about more than. Okay, for the detailings you have to go for the setting this one. Now the next one, that is the rebar selections rule for the beams and columns. So first start with a beam. So here we have specified that the smallest bar size, that is the 12 mm. So you have to just provide that all the 12 mm.
But actually, we have defined that before.
Yes, so we have to also define in the that we have defined in the design part, right? And
Okay,
now we
now
have
in
to also
detailing.
define in the detailing. Okay, and this is the zone, that is the Etabs, that is the zone A, and zone C, that is the end region. Okay, and zone B will be the mid region. Okay, fine. And if your theoretical part will be weak, then you have to just go and prefer that the book that I have referred. Yes or no? So have you purchased or no?
Yeah, sir, I ordered in Amazon.
Yes, so you
I think it will come in 2 days.
Okay, so you just read that. Okay.
I couldn't buy it, Mr. Sono.
So you can also buy, because you have to, your theoretical concept is not very strong, right, Munir?
Yeah.
So you have to read that the book if you want to increase your enhance the skills. Okay.
Like, in which section do you prefer us to start? Because I have found it in PDF file, and
I have just sent that the link on your WhatsApp. That is, and you can go and prefer that the site, that is the Amazon.
Okay.
Yes, Amazon. It is available on the Amazon. Otherwise, you can talk to the Praveen. He also ordered that. So, right.
Sir, one thing, sir, in this ETABs, we should select the bar size, how much we have to prefer.
This is the preferences I have used. Okay.
But
Not this is the
if I
fixed.
don't know,
Not
sir,
this is the
one
fixed.
thing,
Yes, so that's why we use that the preferences. Okay, we have just checked the design. It will be okay or not. If it
one
is,
thing, sir, for me, I don't know how the size we should be
yes,
used.
so yes, so that's why you have to just take that the experience. Okay, you have to learn that the theoretical part. Okay. So according to that, you can justify that what is the size of bars we have to prefer in the structure. Okay.
8. Then zone A, B, C, 8.
Yes, zone ABC, that is the zone A is the end region for the beam and column, and zone C is the end region of beam and column, and zone B will be the mid region.
Yeah, but which preferred bar size?
Yes.
Do you prefer 10 for
No,
zone A?
Minimum that we have to start with 8.
Right.
Okay. Now here we have to provide that the spacing, that
100.
is 100 and 100, and maximum
300.
300 and 300. Okay, that we have to do for the beam, right? Now the next one we have to do for the columns. Okay. When we work on the structure, right? So we do that the little bit part, not go for the complete part. Okay, you have to do one step by step. Okay, fine.
Okay.
Yes, you have to just start that the analysis part and first do that the analysis in the details. Okay, after that you have to go in the design, then do that the design, then detailing. So you will do like that, then you can get that your skills. Okay.
After analysis, we can know our beam and column
structure will be all are depends on that your concept, the theoretical concept. Okay, it is not by the creativity. Design will be done the creativity what you think, but the structure will depends on the concept. Okay, that is all the total theoretical part. Okay, if your theoretical part will be not as strong, it means that you will be on the structure.
But Mr. Sono, like you don't have any PowerPoint slide that explains the theoretical.
It's a vast, so how can we prepare that?
No, for example, you
According
put
to-
the standards, for example, beam.
Yes,
we
yes.
take
For that we have created that the notepad. Okay, so I just send you that. Okay.
Okay, the main the analysis part we should be strong in the I think structural analysis part.
Yes, structure analysis part. Your structure analysis part will be strong. Okay.
So what is the meaning of the BBS or bar bending schedule?
Bar bending schedule, that another things that we have to prepare. Suppose that we have to send that the schedules. Okay. So in that case, we have to prepare that the BBS. Okay. But if you have to send that the drawing, so in that case, we not provide that the BBS drawing.